Hey everybody, Miss Maritello here to talk to you about adding and subtracting numbers in scientific notation today. So say we were given a problem like this, both numbers are in scientific notation, we're asked to add them together. A lot of people would just start by writing both numbers in standard form. If you were to do that, you would get 3,200 plus 4,500, add them together, you get 7,700. Not super difficult, but then if you were asked to write your answer in scientific notation, you just have the extra step of rewriting that 7,700. In scientific notation, you should get 7.7 times 10 to the third. And a lot of people notice, if you were looking at this problem or maybe looking for a shortcut, that you could have gotten the 7.7 by just adding together 3.2 and 4.5. And then, so that would be take care of your first factor. And then as for the other part, the power of 10 just stayed the same, 10 to the third, 10 to the third, and in our answer we just have 10 to the third. So a lot of people notice that shortcut, and in cases where the problems may have a lot of zeros, it is always nice to use the shortcuts. That's why we have scientific notation. So if you were going to see that, you would just be able to add the first factors together as long as you have the same power of 10. So 10 to the third, if they were both 10 to the second, as long as it's the same exponent. You're allowed to do this because of the way that, like, you're just combining basically the like terms. Like if you were to have 3.2a plus 4.5a, then you would just combine them to put 7.7a. And notice if you were to do that with combining like terms, you would not change the a, it would just stay the same. So then the 10 to the third just stays the same. If you wanted to show your work for that problem, a lot of people will write it like, okay, you just added together the 3.2 and 4.5, so they put the parentheses around there to show that you're just adding together the first factors first, and then you keep the 10 to the third the same. If you were to try it with a different problem, notice in this one, first thing you want to check for is, are the exponents the same? Are the powers of 10 the same? Yes, they are. In this particular case, both of them are 10 to the second, 10 to the negative second. So we're good. So we can add together the first factors. We get 6.7 plus 4.1. When you add them together, you get 10.8 times 10 to the negative second. Everything seems great. However, you are not really done. Notice that 10.8 looks a little funny to be scientific notation. Hopefully you remember when you started learning how to write numbers in scientific notation that the first factor has to be in between 1 and 10, or specifically it needs to be greater than 1, but less than or equal to 10. So then you have to change that. So ways that you can change it, some people like to rewrite 10.8 times 10 to the negative second into standard form, which would be 0.108. And then they put the number into scientific notation from there. They find that easier to write it in standard form and then put it in scientific notation. So then once they see that, they know the decimal has to go in between the 1 and the 0, making it 1.0 times 10 to the negative first, because you just moved the decimal one time and it was a small number, so the exponent's got to be negative. However, some people can kind of just see, okay, when I look at 10.8, I know that the decimal needs to be in between the 1 and the 0, so they know because they're moving the decimal to the left one spot that then they'd need to add 1 to the exponent. So the negative 2 needs to become a negative 1. Either way you think about it, it doesn't matter, but your final answer should definitely be the 1.08 times 10 to the negative first. So you definitely would not be allowed to leave your answer as 10.8 times 10 to the negative second if they ask you to write your answer in scientific notation. That would not be, it's equivalent, but it's not technically correct because it's not in scientific notation. Trying it again with subtraction, the rules are basically the same. You need the exponents to be the same. As long as they are, then you can perform the operation on the first factors. And then you just want to be careful, is your answer really in scientific notation or not? So with this one, subtract the first factors, you should get 0.9 times 10 to the second, and notice again, you are getting that the first factor, it's less than 1 in this case, and then the number is not in scientific notation. So just trying that process again so you guys can see it. You could rewrite the number as 90, and then once you have the 90, you know the decimal needs to go in between the 9 and the 0 to be in scientific notation, so you'd have just 9 times 10 to the first, because you move the decimal over one spot. Or you could think that you need to move from 0.9, you need to move the decimal one spot to the right, which would be like multiplying by a 10. So then to keep the number the same, you actually have to subtract 1 from the exponent, because since you were like multiplying by 10 on the 0.9, then you need to divide by a 10 somewhere else to keep the number equivalent. So then to divide by 10, it would be like subtracting 1 from the exponent. So you'd get 9 times 10 to the first. So that works either way. So then your final answer is going to be the 9 times 10 to the first. And the last one that I wanted to do with you guys hopefully should look kind of funny, because when you go to check to see if the exponents are the same, you should notice that they are not. We got a 10 to the third and a 10 to the second, so we're not allowed to just add those together. If you wanted to, you could do the same process we did at the very, very beginning of the video, where you're putting both numbers in standard form, adding them together, and then you put the final answer, the 4890, you got to put it in scientific notation. That's fine. That absolutely works. You could do that. However, if you did want to try to do a shortcut on a problem like this too, you definitely can. The trick that you're going to have to do, though, is you know that the exponents have to be the same. So you're going to have to take one of these numbers, it doesn't matter which one, but you're going to have to change it so that the exponent's the same as the other one. So you could change the first number with the 10 to the third to be 10 to the second, and then you'll have to change the first factor accordingly. Or the 10 to the second, you can change it to 10 to the third, and then change the first factor accordingly. So I'm going to do it. And again, that method that's shown on the screen right now was putting each number in standard form, adding, and then putting the answer into scientific notation. But if you're looking to the shortcut, which I have in the next slide, what I had done here is I changed the 10 to the second to be 10 to the third so that they could be the same exponent. But then when I do that, because it's like I multiplied 10 to the second times another 10 to get it to be 10 to the third, because I multiplied by 10, then I have to divide by 10 somewhere else in the number to keep the number the same, like the inverse operation. So then if I multiplied by 10 here, I need to divide by 10 from the 5.9. So when I do 5.9 divided by 10, it's just like moving the decimal over one spot, so then that becomes 0.59. So if you were to check it, 5.9 times 10 to the second is equivalent to 0.59 times 10 to the third. Sometimes people get a little bit, they don't like that step because they notice that the number is not in scientific notation anymore. That's fine, because we'll still make sure that our answer is in scientific notation. We're just changing that so that then we're allowed to use a shortcut. Because as soon as we see that those exponents are the same, we're allowed to add together the first factors. So then once we have that second step done, then we can add together the 4.3 and the 0.59. And you're going to keep the exponent the same, which is 10 to the third. So then when you add those two first factors together, you should get 4.89 times 10 to the third. And notice in this case, it just already had happened to be in scientific notation. If it was not, if the first factor was smaller than 1 or bigger than 10, you could have changed it. But for our purposes, the number, it's all good on there. All right, hopefully that was helpful. Thanks.